Today I'll take you through what we have done using Autodesk CFD Simulation for evaluating life safety in a basement car park. That's me. Name is Munirajulu, and I have 23 plus years of experience in CFD analysis. And I'm working in L&T as Chief Engineering Manager, responsible for CFD analysis for MEP design. And I've been working on data center cooling, basement car park, DG room ventilation design, and smoke simulation in buildings, including airports, convention centers, and shopping malls. I'll take you through a little bit about what is CFD and what are the advantages. CFD technology uses computer software and high-speed computing workstation. And this computer software is based on fluid dynamics and heat transfer physics. And it virtually simulates how the airflow happens, how the heat transfer happens in buildings. And we have been using Autodesk CFD simulation for quite a number of years in the area of DG and chiller plant ventilation, car park basement ventilation, data center cooling, then smoke simulation in atriums and double height halls in hotels, malls, and airports. The advantages of CFD: you can validate your design, and you can work out alternate design at the concept stage itself. And also you can optimize the design during the detailed design stage. And if there are some problems with the installed systems, you can do the CFD simulation and find out what is the root cause and try to address that problem. And the significant benefit of using CFD analysis is that you will get quantitative and visual information, engineering information that will help you to arrive at a good design. Now, what is the business scenario and target area for using CFD? There is a shift from prescriptive design, that is code-based design, to performance-based design, and that is where we can start using CFD simulation and using tools like Autodesk CFD. And there is also a shift from design and build to design, make, and build, meaning there is emphasis on modular construction. And also virtual design. Because virtual design is possible, now using BIM tools, you can actually use Autodesk CFD in the process of integrated design. And international codes make allowance for using engineering analysis to validate the design. So that is why we can use the CFD analysis in the design. And the target areas, as I mentioned already, because there is a focus now on performance-based design instead of prescriptive-based designs, we can start using CFD as an effective engineering analysis tool. And usage of CFD tool supports the virtual design before construction. And today I'll take you through these 4 focus areas: how the airflow, fluid flow, or heat transfer is modeled in Autodesk CFD. Then what are the simulation strategies and techniques, and the key results for basement ventilation, and advantages and limitations. In the design of MEP systems, usually airflow or fluid flow is involved, and heat transfer also is involved. And if we are able to simulate how the airflow or the fluid flow happens along with heat transfer, then we will be able to understand how the design works. And CFD is a process. There are 4 stages mainly. And stage A and B, the inputs come from the design team, CAD model, and the engineering parameters for boundary conditions. Then from stage C and D onwards, the CFD analyst contributes it in terms of using that CAD model to create a CFD model, then applying the boundary conditions, meshing, and then extracting the CFD results. So in the airflow modeling, you need to create a fluid domain from the CAD model, and then you include all the obstructions to the flow, and the supply and the exhaust conditions. And in the heat transfer, mainly forced convection, where airflow happens and the heat transfer happens simultaneously. And in many cases, natural convection happens because of the temperature differences and the buoyancy conditions. So now I'll take you through what we have done in the basement car park case study. So there are two modes of ventilation in the basement car park. Why basement car park is these days in the commercial buildings and the residential buildings, basement car parks have become a common feature, and life safety is very important, both during the normal operation of the car park as well as in the fire hazard situations. And there are two modes: normal mode, where the CO is a contaminant, can be a life hazard, and then in the event of fire happening in the car park, the smoke can be a hazard to life safety. And usually normal mode is designed with a 6 ACH ventilation, and fire mode is designed for 12 air changes per hour ventilation. Now, although Autodesk CFD can be used for both normal mode and fire mode, I'll cover only the fire mode, how we have used it and how we have evaluated the life safety. This is the basement car park layout, architectural drawing, and it has 4 zones, and we have done CFD analysis for 1 zone, which is typical. And this is the HVAC scheme with supply and the exhaust. Supply is ducted, and exhaust is axial fans with the jet fans to move the air towards the exhaust. And how the jet fan works: jet fan actually pulls the contaminated air from a lower level and throws it to the higher level, so that occupied place can be free from the contaminants. And that's why jet fans are used. And this is a typical CAD model that we use for basement ventilation CFD analysis. We have to include columns and ventilation ductwork and other major flow obstructions. This is the jet fan layout. And then boundary conditions are very important for us to get proper results. So we represent a car fire with a 4 megawatt volumetric heat load, and then we specify the inlet and outlet conditions, and the ambient temperature, and then this I have mentioned already. So car fire is modeled based on the BS standard 7346, and 4 megawatt car fire with a 10 meter square area. This input is very important because code specifies it, and we can use it. And typical model setup includes creating the air domain and then assigning the air properties. And of course, here, since high temperatures are involved, we specify as a variable density for the air. And jet fan we modeled as a fan with a volumetric flow rate. And meshing is, of course, very important to get accurate results. And fire part is meshed with 4 to 5 uniform elements to evaluate the proper heat transfer. Then the smoke visibility depends on the combustion particulate yield and the signage constant and the specific extinction coefficient. These are the inputs that we have to give based on the type of fire. So this we have to give it to Autodesk CFD as an input. And then since both flow and the heat transfer happens, we have to enable both flow and the thermal options from the physics tab. And gravity, we have to set downwards because buoyancy is involved. Then in the advanced option, we have to set up general scalar because then the software will start calculating the smoke generation. Again, this solver settings I have covered already. Now, key results for basement ventilation evaluation for fire mode. Basically, we look at smoke visibility and the smoke temperature because these determine the life safety. Can we have the video here? Yeah. So using CFD, you can actually visualize how the smoke propagates in the event of fire in the basement using isosurface plots. Again, the video, please. Yeah, what happens in the real fire also, smoke actually will go to the ceiling level, and then from there it will try to move. So in the CFD also, we can see how the smoke is generated and goes to the ceiling level and then spreads towards the exhaust. It's close to reality. You can see a real car fire on the side. And how the jet fans help. Can we play the video? Yeah, jet fans actually move the smoke and the contaminant from a lower level, and it throws to the exhaust so that the occupied levels will be free from smoke. So this slide indicates how the jet fans move the smoke towards the exhaust. Now the acceptance criteria, it's based on BS standard. You have smoke tenability, that is smoke visibility of 10 meters, and then temperature tenability of 60 degrees Celsius. Beyond 60 degrees Celsius, people will get skin burns. And toxicity, like carbon monoxide, that is deemed acceptable if visibility is more than 10 meters. So from the CFD, you can actually get the smoke visibility values. And here you see smoke visibility at 0.7 meter. And here you can see that most of the basement is free from smoke. Therefore, and visibility is greater than 10 meter. And similarly, at 1.7 meter, that is the head level, occupied head level for people, the breathing level actually. So at breathing level also, we have the basement free from smoke. I will show the results on the evacuation paths. So this is the evacuation path I have highlighted in the red arrows here. So along the evacuation path, if you look at it, so you can see this is a 3D slice. So here you can see that along the evacuation path, the visibility is more than 10 meters, up to a height of 1.7 meter. Therefore, it is safe for people to move out in the event of fire. And again, the other side of the 3D slice. Another significant parameter that decides life safety is the smoke temperature. So here you can see the smoke temperature plots extracted from CFD. At 0.7 meter level, we see that the temperatures in the basement mostly is less than 60 degrees. And at 1.7 meter also, it is less than 60 degrees. And this is how the jet fans will move the smoke-laden air towards the exhaust. Is a jet velocity profile, actually, this. And so the outcome for the final design is you look at the smoke visibility and you look at the smoke temperature. If these two are meeting the tenability conditions, then your design is okay, your design is acceptable. If not, you modify the design, rerun the CFD analysis, and see if these tenability conditions are met. So based on these results, we conclude that the design is acceptable. And I'll just touch base on the advantages and limitations of using Autodesk CFD, more benefits than the limitations. And it's easy to use, and we can quickly validate the design for smoke control strategy. And it's an engineering-based approach and performance-based. And interface with Revit for getting the CAD model for CFD is relatively easy, not so easy, but relatively easy. And CFD analysis gives more insight into the design, so you'll be able to actually understand and optimize, innovate the design. And the limitations, it is time consuming because CFD as such it takes a lot of time and computing power. And then the smoke generation in Autodesk CFD is given as a scalar, not in terms of the quantity, so that is a limitation. And then tenability for fire brigade to reach that radiation values are important. Autodesk CFD, we have a challenge there. And also, another thing we have to remember when using CFD analysis that there is a limited verification of the smoke control strategy, so we have smoke modeling, so we have to be careful on that. And if you have any questions, you can meet me at the end of this session. And thank you for listening. And if you want to reach out to me, my mail address is here. And finally, I thank Autodesk India for giving me this chance to present here. And last 2 years, I've been presenting at Autodesk University, Las Vegas. And this year also, I'm going to present there. So thank you so much for listening.